Good morning, my dear students. I am welcoming you to my YouTube channel Learning Island. Today, I have come up with you with multiple choice question from chapter 4 of class 12 physics. These questions are very much important for your upcoming exam. It will be useful in your monthly exam, monthly test in the school, or also in your board exam. You can also go through my previous 3 videos on these MCQs from chapter 1, 2, and 3. You will get the link in the description. Okay, so I hope this kind of video would be very much helpful for you. So let us start without any delay. Okay, so see, the first question is the SI unit of magnetic field is. Let us see the options: Weber, Tesla, Oersted, Maxwell. So you see, these all are the name of the scientist. हम जानते हैं कि दी साइंस में यूनिट्स जो है ना मैक्सिमम केस में साइंटिस्ट का नाम के साथ रिलेटेड होता है। यहाँ पे देखो आंसर होगा टेस्ला। फिर जो वेबर, ओर्स्टेड, मैक्सवेल वो क्या है, अभी मैं थोड़ा डिस्कस कर लेता हूँ क्योंकि ये ना बहुत बहुत कंफ्यूजन रहता है हमारा। ये कंफ्यूजन दूर करने के लिए मैं थोड़ा डिस्कस कर लेता हूँ। ये जो जस्ट 1 मिनट, जो टेस्ला टेस्ला क्या होता है एक्चुअली? टेस्ला मीन्स वेबर पर meter square. So this is the SI unit of magnetic field, but here it is in Weber. So Weber is the actually unit of flux, you can say magnetic flux. Okay. Now, so answer is Tesla, and Oersted. It is also the unit of magnetic field. You know, you can say intensity, not the unit of magnetic field. It is the magnetic field intensity. Now, it is SI unit. If the questioner asked, what is the CGS unit of magnetic field? Then answer would be Gauss, G-A-U-S-S, Gauss. Okay, let us go to the next question. Next question is Biot-Savart law is analogous. Biot-Savart law किसके साथ similarities है? Gauss law in electrostatics, या Coulomb's law in electrostatics, या Lange's law, या laws of conservation of energy. तो इसके लिए आप लोगों को ना ये सारे लॉ पता होना चाहिए, नहीं तो फिर सिमिलरिटी नहीं कर पाएंगे। तो ये अभी मैं सारे डिस्कस नहीं कर रहा हूँ, आप लोग इसको बुक में चेक कर लेना। Here answer would be Coulomb's law in electrostatics. So how it is related? You see, Coulomb's law में क्या होता है, मैं थोड़ा डिस्कस करता हूँ how it is similar so that you can understand properly. In Coulomb's law क्या होता है, इलेक्ट्रोस्टैटिक फोर्स इक्वल टू होता है K into Q1 Q2 by R square. That means here F is inversely proportional to R square. In case of Biot-Savart law, the magnetic field equal to होता है μ0/4 ये सब फॉर्मूला आप लोगों को सीखना पड़ेगा, रट्टा मारना पड़ेगा, तो जाके एग्जाम में टाइम मिलेगा। ओके, you cannot, recall if you do not understand properly. So, कुछ किस में रट्टा भी मारना पड़ेगा. Okay. So the formula is IDL sine theta by r square. So here also you see this is the constant part, and IDL is also, you can say, constant. It is not constant part. I is variable, DL is variable, sin theta is variable. It is also R is variable. So FB varies inversely square of distance. So these two are similar with Coulomb's law. Okay, there is another similarity also. It is only for long distance point charge. Here is also for long distance. So the answer will be Coulomb's law. But it I am not going so much deep. Otherwise the video will be get longer. So you can go through my other videos on this chapter, theoretical parts, which will be clear to you. Okay. Otherwise you can put me a question on the description in the comment section. I'll get back to you. Now go to the next questions. Formula for magnetic dipole moment M in terms of this one drawing. Okay. Now the question, you can say, formula for magnetic dipole moment M in terms of turns, number of turns, that is where जो turning करता है ना, 2 turn, 3 turn, 4 turn, n turn, radius of those circular position sizes are area A and current I. Then what is the answer? Okay, that means the question is like this. If an wire is like this, if 1 turn, 2 turn, 3 turn, 4 turn, I say number of turn is equal to n, number of turn. So in this case, if the radius of this r and the cross and the area and area is a, area of this is a, current I will be, करंट कितना होगा. तो इस केस में एक फॉर्मूला आता है मैग्नेटिक डाइपोल का. दिस इज इक्वल टू एन आई ए, करंट फ्लो, एरिया एंड नंबर ऑफ टर्न्स. इसका भी डेरिवेशन है, ये भी अब थियोरेटिकल पोर्शन में मिलेगा आप लोगों को. ओके, सो द आंसर वुड बी NIA. Now next questions. A particle of charge Q moving with a velocity v perpendicular to it is not uniform, it is uniform magnetic field B in a circular path of radius r has a momentum. Momentum क्या होता है? अगर ये सर्कुलर पाथ में घूमता है तो मोमेंटम क्या होता है? कोई भी इलेक्ट्रॉन्स, you see, suppose this is some magnetic field or electric field, an electron is coming here and it start moving in the direction round. So if it is the circular path radius is r, it is moving with the velocity v, and it is in a magnetic field. The magnetic field is B. So here the momentum mv equal to होता है r b q. ये कैसे होता है? इसका भी डिराइवेशन है. ओके, इसका ऐसे होता है कि जब ये घूमता है, इसका इनवर्ट का तरफ एक फोर्स फील करता है, सेंट्रीफ्यूगल फोर्स और सेंट्रीपिटल फोर्स. ओके, तो ये जो सेंट्रीपिटल फोर्स है, ये होता है, एक फॉर्मूला है, ये इक्वल टू होता है बी क्यू v sin theta. Theta is the angle between the magnetic field and the velocity vector of the particle. Now here you know B, QB, and also there is a centripetal force outward. It is mv square by r. Because if the radius is r and something is moving, so it will feel a centripetal force outward. So this force must be equal to the centrifugal force, this force. So comparing this, we can get, see, BQV sine theta, okay, equal to mv square by r. So here, if we put the angle 90 degree, because in this case it is 90 degree perpendicular, so it will be BQV sine 90 degree equal to mv into v by r. One v will get cancelled, tangent is 1, so BQ equal to mvr. So their momentum, if I make it like this, mv whole square, so I should divide it by m. Okay, momentum, we are finding out the momentum. Okay, so that would be bq, what is coming, mv square by r, bqb mv square by r equal to mv square. From here it is coming like this, it will be m square more into r. So from here we can get r equal to m v, r equal to mv by dq, means r equal to this, these cancel, it is only like this, mv by r equal to mv by bq. So mve means momentum, so bq. So radius is coming bq and momentum is coming t equal to r bq. So this is the answer. I think you got it. Okay, now go to for the next question. I am trying my best to explain in between, but trying to shorten the video. Okay, that's why I am not going so much deep. If it is not being, if you are not being able to understand properly, you can also comment me. Okay, I'll get back to you. Next questions. In a certain region of spaces, electric field E and magnetic field B are perpendicular to each other. An electron moves undeflected. The velocity of electron is, see here, velocity of electron B. In a certain region of space, electric field E and magnetic field B are perpendicular, okay, to each other. An electron moves undeflected. The velocity of electron is, okay, इसमें in a certain region of space, electric field E and magnetic field B are perpendicular to each other. So here, what will be the answer? Without any deflection means, I'm going to show you the basic things, because without basic thing you cannot understand this. Suppose this is the direction of electric field and this is the direction of magnetic field, because they had already told that in a certain region of space, electric field E and magnetic field B are perpendicular. So this is the electric field direction, this is the magnetic field direction. Now, an electron moves undeflected. If an electron reach to this region and it is not getting any deflection, if the electron is moving in the direction, it will move in the direction. No deflection, no effect of magnetic and electric field is happening here. That means here the field, net field produced by the magnetic field and electric fields are equal. That's why it is not and opposite. That's why it is not getting any deflected. Net field is zero. So on the basis of this, we are going to find out the answer here. So if any electron with Q charge moving in an electric field, then force due to electric field is equal to, we know, Q into E, and force experienced by magnetic field B equal to B Q V sine theta, where theta is the angle between the magnetic field. So here, if these two would be equal, that's why it is not getting any net force. So if F equal to AB, then we can write QE equal to BQB sine theta. B, here Q would be get cancelled by Q. Okay. So, and the angle between here is what? In a certain region of space, electric field E and magnetic field are perpendicular to each other. The electron moves undeflected. The velocity of the electron is. So here the angle, they are perpendicular to each other. So the angle would be 90 degrees. So sin 90 equal to here B sin 90. So that is BB. So E equal to BB. So we have to find out the velocity. So B would be E by B. Okay. So I think there is answer. Yes, this is the answer. So hope this is clear to you. Okay. Now see the answer given here. Answer is E by B. So go to the next questions. The net force on the electron moving in the magnetic field 2 Tesla with velocity 4 into 10 to the power 4 meter per second and angle 30. So it is very easy. This is the option. We will use formula. मैं बार बार बोल रहा हूँ आपको फॉर्मूला रट्टा मारना पड़ेगा बहुत सारा. Here the force of an electron, I've already told you the force, magnetic force equal to BQB sine theta. This is the force. If it is magnetic field in the direction and if any electron start moving with a velocity v in the direction, angle is theta, then the force is equal to F B, magnetic force equal to BQB sine theta. Okay, here BQB all are given. So if you put those value, we will get the answer. Okay, so you can find out this by using this formula. Okay, formula is B equal to BQB sine 30 degree. Here they mention the angle is 30 degree. So put B is, the value of B is VB, velocity is meter per second, and magnetic field B, this is the value of B, 2 Tesla, and this is the value of theta. So if we put all this, we will get the value as 6.4 into 10 to the power minus 15. Okay, so this is the answer. So let us go to the next question without any delay. Okay, now the next question is, a wire carrying a current I is placed in a uniform magnetic field so that it experiences no force in the field. the angle between the direction of magnetic field and current will be 90 degree, 0 degree, will be 0 degree. Okay, will be 0 degree. How? Same formula, same formula. I'm again showing you. Question is a wire carrying current I. Suppose a wire is carrying current I. This is carrying current I. Is placed in uniform magnetic field so that it experiences no force. अब इसको अगर यूनिफॉर्म मैग्नेटिक फील्ड में फेंकते हो एंड इसमें कोई फोर्स भी फील नहीं करना है, either this should be put a magnetic field which is parallel to this in the same direction or it is in the opposite direction. Okay, why? Because the force field, what is the current means flow of electron. If current is flowing in this direction means electron is flowing in opposite direction. So electron when flows in a magnetic field, the force filled by it, again formula QB sin theta. Now it has been said that it is feeling no force, means if theta is 0, then the value of sin 0 would be 0, or if theta is 180, then also there will be 0. So you can put this here. In the answer there is no 180 degree, so there is 0 degree, so answer will be 0 degree. Okay, hope it is clear. Now go to the next question. An electron and a proton enter in an uniform magnetic field perpendicular to the field of direction with the same momentum. Okay, same momentum लेके ये एंट्री किया. Electron uniform magnetic field. An electron and a proton in a uniform magnetic field perpendicular to the field direction. Suppose this is the direction of uniform magnetic field. So an electron enters perpendicular to this direction, and the proton is also entered in the perpendicular direction. Okay, field direction, the same momentum is same, that is the P here, P of electron and P of proton is equal. The ratio of the radius of circle traced by them will be, when it moves in an electric field, it will move not, it enters in a perpendicular direction, but after entering the electric field, it will moves in a circular way, So this will be the radius. So question has been asked, which radius is RE or RP? मतलब जब कोई मैग्नेटिक फील्ड में कोई इलेक्ट्रॉन या प्रोटॉन जाता है ना विथ वेलोसिटी v, then its path, it is coming in the direction after entering this area, इसका path because of magnetic field ये सर्कुलर पाथ में घूमते रहते हैं. ठीक है, तो इसका एक रेडियस होगा. वो रेडियस अगर इसके अंदर प्रोटॉन जाता है तो प्रोटॉन भी एक सर्कल में घूमेगा, और इलेक्ट्रॉन गया वो भी एक सर्कल में घूमेगा. किसका रेडियस ज्यादा होगा, ये क्वेश्चन में बोला गया. सो रेडियस का एक फॉर्मूला होता है. ओके, तो वो फॉर्मूला अगर आप अप्लाई करोगे तो आपको ये मिल जाएगा. कैसे? ये देखो, ये जो रेडियस है इसका ना, हियर इट हैज बीन told that the momentum is same. So we know momentum P of electron, momentum of electron would be, formula was like this. If it is P of momentum of electron and P equal to momentum of proton, then we can use RE equal to momentum by B Q. This is the formula. And R, P would be momentum of proton by BQ. So here PP and PE are equal. So we can write RE by RP equal to 1 by BQ by 1 by BQ. 1 by BQ, that is, it will get cancelled. So it will be 1, it is 1 is to 1. So the ratio would be 1 is to 1. Is it? So the radius of circular path traced will be, let us see the options. Options are, you see, what is the option? Just a minute. Is to 1, 1 is to 1 is here. So answer will be 1 is to 1. Next question. An alpha particle and a proton enter in a uniform magnetic field perpendicular to the field direction with the same momentum. Find the radius, ratio of the radius of the circle placed will be. This question is similar to these questions. So I hope you will be able to answer these questions. Let us repeat the descriptions. This is the answer, okay? Now, next question. Two long parallel wires placed 20 cm apart, covering equal current, each 5 ampere in same direction. What is the magnetic field at the midpoint on the line joining them perpendicularly to those wires? So options, let us see the options. Here the answer is 0. How? You see, question is two long wire placed 20 cm apart. Suppose this is one long wire and this is another long wire. The distance between them is 20 centimeter. Okay. Conveying a current of 5 ampere in the same direction. So this current equal to 5 ampere. Here it is also carrying a current I equal to 5 ampere. So when the currents are flowing parallel, then they feel an attractive force in this direction. Both the wire gets an attractive force. So what is the magnetic field at the midpoint? Here the midpoint is midpoint. Here it is 10. This 10. In the midpoint, what is the magnetic field? That is the formula for magnetic field in the midpoint. Okay, at any point you can say. So by using this formula, we can calculate this answer. Okay, how? Here you see, we know the current is flowing in this direction. So the magnetic field, if we apply the right hand rule, then also we can find it out. Because of this line, the magnetic field would be in this point downward direction. Okay, and because of this, the magnetic field here will be upward direction, and they will be equal, so they will cancel each other. Okay, so here the magnetic field is 0. ओके यहाँ पे आपको फॉर्मूला यूज भी नहीं करना पड़ रहा है क्योंकि हम जानते हैं जो रूल्स अप्लाई करके हम निकालते हैं स्क्रू रूल से भी कर सकते हो एंड हमारा इफ यू पुट योर thumb finger towards the direction of current and if you आपका बाकी जो उंगलियां उसको अगर आप घुमाते हो तो ये किधर घूमता है तो ये जाएगा ऐसे घूमेगा ये ऐसे घूमेगा तो ये जाएगा डाउनवर्ड और इसके लिए ये ऐसे घूमेगा तो ये एक दूसरे का ऑपोजिट में है ठीक है सो ये एंड एज द डिस्टेंस are same and the current carrying is also same, so the force will be same. That's why they will cancel each other. So here magnetic will be 0. Got it? Okay, let's go to the next question. Next question. Okay, just 1 minute. Yes. The next question is, if in previous question the wire carrying current in opposite direction to each other, then what is the magnetic field at the midpoint between the wires? Lego. अगर ये प्रीवियस क्वेश्चन, दिस आर द ऑप्शंस, अगर ये प्रीवियस क्वेश्चन में ये जो वायर था, ये दोनों वायर में करंट अगर एक में अगर इन डिरेक्शन, इसमें अगर अपोजिट डिरेक्शन में कर दिया जाता, तो यहाँ पे जो मैग्नेटिक फील्ड होता, इसके लिए होता इन डिरेक्शन, इसके लिए भी इन डिरेक्शन। सो दोनों ऐड हो जाएगा। अब आ गया ये वैल्यू, कितना वैल्यू होगा, अब तो कैंसिल नहीं होगा, तो मेरे को वैल्यू निकालना पड़ेगा। ये पे जो वैल्यू होता है बिकॉज ऑफ करंट आई एट ए डिस्टेंस डी, सपोज डिस्टेंस डी, सो अभी आपको ये निकालना पड़ेगा। ठीक है, तो ये फॉर्मूला होता है बी, बी इक्वल टू म्यू जीरो बाय 4 पाई into 2I by d. D is the distance, I is the current, mu 0 and 4 pi is the constant, and its value is equal to 10 to the power minus 7 is a constant value. Okay, so if I put here 10 to the power minus 7 into 2 into 5 ampere by d is what? D is 10, because the total was 20, so in the middle it will be 10. It is in centimeter, so divided by 100 meter. Okay, on calculation you will get b equal to 10 to the power minus 5 Tesla. And here again there will be a field because of this current, so this will be added up. So total b would be equal to b, it is b1, if b1 for this current and b2 for this current, then b1 plus b2 would be 10 into 10 to the power minus 5, 10 to the power minus 5 plus 10 to the power minus 5, it will be 2 into 10 to the power minus 5. Okay, so this will be the answer. So hope this is clear to you. So let us check the answer. The answer is yes. Now go to the next question without any delay. Which option is correct about the force for question 10 and question 11? Attractive in question 10, attractive in question 11, repulsive in question 10, repulsive in question 11. देखो, if the currents are flowing in the same direction, then it's attractive. So attractive in question 10. This is the answer. If A is the correct option, and also in case of 11, repulsive force. Yes, option D. So the correct answers are A and D. Now, a wire loop PQRS is constructed by joining two semicircular coils of radius R1 and R2 respectively, as shown in the figure. If the current flowing in the loop is I, the magnetic induction at the point O is, तो O पॉइंट में क्या होगा, ये सारा ऑप्शन है। सो देखो ये भी एक फॉर्मूला, तो फॉर्मूला ही सीखना पड़ेगा। ये अगर ऐसे होता है टर्निंग, here the number of turn is 1, so because of this turn, if the current is I, there will be magnetic field. Because of this turn, there will be another magnetic field, and because of this turn, they are in the same direction, in the same line, so there will be no magnetic field because of this current flowing in this line, because they are in the same line of action. So because of this semicircular point and this semicircular point, there will be magnetic field. So formula is that because of smaller circular wire B1, it will be mu 0 by I by 4 at R1. Okay, and B2 would be mu 0 by R4 R2. Okay, radius, ये फॉर्मूला है। अब देखो because of this, the magnetic field direction will be like this, and because of this, magnetic field will be like this. Okay, got it? So they are in the opposite direction. Current is flowing like this, so this would be, no, this is wrong, this should be like this, this is like this. See, in this, here the direction of magnetic field will be in the direction, because of this, and because of this it will be here, it will be in the direction. Okay, now it is in opposite direction. So just I'm rubbing it again, fresh. Because of the current is flowing in this direction, if we put my thumb finger in this direction and make the curve of the other finger, then it will be like this in the direction. And here, if I do this, this will be in the direction. So they are in opposite direction. So the magnetic field here will be uh, minus, that is B1 minus B2. B1 is mu 0 by 4 I, mu 0 by 4, here it is I, and 1 by R1 minus, this is the mu 0 I by 4, 1 by R2. If I take common, I will get this figure. This is the answer. Okay, formula तो याद रखना पड़ेगा. Okay, now a wire of length 6.2 meter is bent into a circular coil of 2 turns. If a current of 0.5 ampere exists in the coil, then so this is, now let us go to the options. Options are these. So what is the answer? See, here the number of turns, n equal to 2 and I equal to 0.5 ampere. We know magnetic field, magnetic moment, okay? Magnetic moment equal to NIA. This is the formula. So if we put here, we know if the current 2 turns, n equal to 2 and I equal to 0.5, and we don't know A. Again, it has been turned to 2. So if it is R, radius is R, here 2 into 0.5 into pi r square. Okay, so we have to find out the value of R. So it is 2 turns. So the perimeter of this wire is 2 pi r into 2. Okay, so this would be equal to the length of the wire. So this would be equal to 6.28. From here I will get R. Okay, and if you put R here, we will get the answer. That answer will become pi by 4. I think this is clear to you. Okay, so now go to the next questions. Next questions. You see, so this is the answer by 4. Next question is, a uniform electric field and a uniform magnetic field are acting along the same direction in a certain region. If an electron is projected in this region such that its velocity is obtained along the direction of field, then the electron will turn towards left direction and the electric field will turn toward the right. Speed will decrease, speed will increase. So what will happen here? Speed will increase, speed will decrease. Why? See, let us discuss this. The question is what? Question is said that the uniform electric field and uniform magnetic field are acting in the same direction. Suppose this is the line of electric field, and this is also the line action of magnetic field. In the same direction, electric field and magnetic field are working in the same direction. If an electron is projected in this region such that the velocity is obtained along the direction of electric field, and the electron is also coming in the same direction. So the angle between the electric field and the velocity vector of the electron is 0 degree. Okay, and also with magnetic field it is 0. So here you see the electric force due to electric field is equal to Q into E. It is not 0, it will be in the opposite direction. Q, it is electron, so electron is flowing in this electric field, so the force would be in the opposite direction. If it is proton, then the force would be in the same direction. Now the force is in the opposite direction, and because of magnetic field, the force is QVB sin theta. दिखाया था यहाँ पे theta is 0, so the magnetic field is 0. So in this case, the electron is not feeling any magnetic field, only feeling electric field, and that electric field is in the opposite direction. So it is moving in the direction. So definitely, if it force is being applied in the opposite direction, so the speed will decrease. Hope you got the answer. Let us go to the next questions. Okay, I am just making it fast. A long state conductor P carries a current I, while another parallel long state conductor Q carries current 2I in the same direction. The magnetic field midway. Okay, you go to these questions. These are the options. I am just trying my best to make you understand. This is the answer also. So how it has come? First, okay, suppose this is a wire. This is another wire. Okay, what is said here? It carries a current. Suppose it is P and it is current carrying current I. And another wire parallel to this parallel wire, it is also carrying a current of 2I. Okay, in the same direction. The magnetic field in the midway, in the midpoint, there is a magnetic field B. If the current 2I is in the conductor Q is switched off, now suddenly this current is become 0. Then what will be the magnetic field between this? See, if it is 0, the magnetic field would be happen because of only this current. Okay, and the formula is that formula for magnetic current here is B equal to, the general formula is, suppose it is B dash, general formula is mu 0 by 4 pi. I've shown this earlier, 2I into by D. D means the distance. So only because of this current, the magnetic field would be this much. But I'll have to express this in terms of B. So फर्स्ट ऑफ ऑल कंसीडर कि 2I करंट भी है जिसमें है एंड I करंट भी इसमें, तो अब ये क्या होगा, ये जो B है म्यूचुअल, इसमें क्या होगा, सी यहाँ पे बिकॉज ऑफ दिस करंट देयर विल मैग्नेटिक फील्ड, बिकॉज ऑफ दिस करंट देयर विल मैग्नेटिक फील्ड एंड बोथ वुड बी इन ऑपोजिट डायरेक्शन. So the net magnetic field here B would be equal to like this, B1 minus B2. B1 is for this, B2 is for this. So it will be mu 0 by 4 pi 2 into 2I by minus I. How it is happening? 2I because of this current. 2 is the formula. I put this formula here. Mu 0 by 4 pi. 2 is this formula and 2I is this current minus, because this for this current. Suppose B2, B1 will be, if it is B1 and it is B2. So B1 will be this current is 2I, so 2 into 2I, and because of this mu 0 2 into I, if we, because these would be in the opposite direction, so finally we are getting mu 0 by 4 pi into 2I. This is actually equal to B dash. Okay, and this amount is equal to coming B dash, right or wrong? Okay, that means B dash is equal to B and it will be in the negative direction. That's why here it is B dash answer. Okay, so hope it is clear. I'm just going a fast. Now come to the next question. An electron enters a uniform magnetic field of flux density B, this, with a velocity this, and x direction. So question is respectively an electron enters information with a velocity B. So the both speed and the path will be changed. Change होगा क्या नहीं? Speed will be changed. The path will become circular. Neither speed nor path will change. So which one is correct? Here you see the direction देखना पड़ेगा. देखो इसमें जो है ना, this is the magnetic field and here this is the magnetic field. If I take common here 2, then this will be I plus 3 minus root 2 k. Is it? Yes. So see, this question and this question are same. When this kind of equation we get, they are parallel. So in both this case, the electron enters in magnetic field of flux this with the velocity. So velocity and magnetic field are in the same direction. Okay. So when the velocity and the magnetic field remains in the same direction, then there will be no magnetic force. So here the path so here the magnetic field path will not change. Okay, so hope you got this answer. This is the neither speed nor path will be changed. Okay, now come to the next question. A proton enters in a uniform magnetic field at an angle 30 degree with the field with velocity b. Its path will be c. Its path will be helix. Okay, whenever any electrons or photons enter in a uniform magnetic field, the velocity at an angle or in a perpendicular direction, proton enters in the magnetic field at an angle 30 degree, then it will be, if it is perpendicular, then it will be circular. If it enters in an angle, then the path become helical. Okay, so theory question is there, so go through this theory. I'm not going into the theory part. Okay, so let us go to the next question. Next question is, an electron is projected horizontally from south to north in the uniform horizontal field acting from west to east. The direction along which it will be deflected by the magnetic field, it is vertically upward, vertically downward. See, this is the answer. But now let us explain what is going on actually. Okay, an electron is projected horizontally. So this is the horizontal direction. Electron is coming from this side. Okay, and from south to north. It is south, it is north. Okay, and magnetic field acting on the west to east. So north south. So what will be north south? So it will be east to the west. So west to east. Another, it is in the magnetic field is in this direction. So the electron along which will deflect by the magnetic field. So it is perpendicular. See, it is perpendicular. Okay. So if it is perpendicular direction to the electric field, an electron is projected horizontally from south to north in a uniform horizontal magnetic field acting from west to east. The direction of along which the electron moves deflected in the magnetic field would be vertically upward. Okay, there we can use Fleming's right hand rule. Okay, I hope you know Fleming's left hand rule. use करके भी कर सकते हो. Okay, if you put your thumb finger in the direction of force and fourth finger in the magnetic field, the current will show the middle finger will show the current direction. Okay, so hope no need to explain more. So let us go to the next question. A proton is projected horizontally eastward in an uniform magnetic field which is horizontal and southward in direction. The proton will be deflected. This question is similar to the previous question, so I am not discussing this. So if you feel you can find it out by using the Fleming's left hand rule. Okay, so if it is any finding difficulty, you can get back to me. ओके, अगर प्रॉब्लम होगा तो मेरे को डिस्क्रिप्शन में लिखना कौन सी क्वेश्चन में प्रॉब्लम आता है, आई विल गेट टू यू. ओके, और आल्सो यू कैन कॉल मी. And at what angle an electron must enter in an uniform magnetic field so that the force experienced by the maximum, it is maximum के लिए 90 डिग्री होना चाहिए. Okay, because the formula is QBB sin theta, so theta is 90 degree, the maximum value of the sin theta. This is very easy questions. When a galvanometer is converted into an emitter, when which statement is correct? See, ये भी मैं अभी अंदर नहीं जाऊंगा because इसका ऊपर भी एक टॉपिक्स है, how the galvanometer can be converted into emitter and how an emitter can be converted into galvanometer. So the answer would be C. That is a low value resistance is connected in parallel with the galvanometer. Okay. Now let us go to the next questions. An electron and a proton enter in a uniform magnetic field perpendicular to the field's lines at the same speed with which statement is correct. The radius of the circle created by the electron is greater than the proton. The radius of the circle traced by the proton is greater than the electron. The radius of the circle traced by the electron is equal to the proton. Nothing can be predicted. Nothing can be not protected. It is nothing can be predicted. So we see the radius of the circle traced by the proton is greater. Why? This question needs to be discussed deeply because lots of things are needs to understand over here. You see, if in a magnetic field, if electron is moving, okay, and a proton is also moving, an electron and a proton enter in from the magnetic field perpendicular to the direction, and the directions are perpendicularly. So if you move in a circle, previously I have discussed the questions regarding this. Here it will move like this direction. So the radius, which will be more radius. See, the formula for radius in this case would be momentum mv by bq. So if it is for electron and it is for proton, that will be mv by bq. Q is same, b is same, velocity is same, only mass is not same. Okay, so definitely mass of proton is more than the mass of electron. So here radius of the proton will be more. Okay, got it? So hope this is very easy. Now go to the next question. देखो इसमें फॉर्मूला के जादू है, फॉर्मूला आपको याद रखना पड़ेगा. Now an electric current passes through a long straight copper wire at a distance 5 centimeter from the straight wire. The magnetic field is V. The magnetic field at 20 cm from the straight wire would be. It's also very easy. So these are the options. Now, how can you get this answer? This you can use this formula. Okay, I'm showing you. Try it yourself. B. The magnetic field B. The formula is mu 0 by 4 pi into 2I by d1 d. So this is the amount of current, the distance, and mu 0 by 4 pi is a constant value, that is 10 to the power minus 7. You can use it here. See, first of all, find out the value for 5 centimeter. 5 centimeter means 5 semi equal to 5 by 100 meter, because here you have to use the SI unit, not the CGS unit. तो SI unit में मीटर सेंटीमीटर से मीटर जाएगा तो 100 से डिवाइड होगा obviously. And by this way you can find out the value of B. After finding out the value of B, you find the value of B dash, that is magnetic field at 20 semi from this. So it will be easy to find it out. Okay, see, B1 for 5 centimeter it will be 10 to the power minus 7 into 2 into current is what, don't know, I suppose, and D is 5 by 100. And for 20 centimeter B2, 10 to the power minus 7 into 2 into current is same, 5 by little bit 5, it will be 20 by 100. If you divide these two, you would get B2. Okay, this would come B by 4. So no more details. So this is the answer. Let us see the answer. Okay, hope it is very easy. So this is the answer. Now for the next questions. A solenoid has 1000 turns per meter length. The number of turns is 1000 per meter. If a current of 5 ampere is flowing through it, then magnetic field inside the solenoid is. Here is also a formula. Okay, we'll have to use formula. This is the options. What is the answer? You have to use the formula. Formula is equal to the magnetic field inside a solenoid is equal to mu 0 and I. N is the number of turns per minute length, and I is the current. Mu is the constant. Okay, so value of mu 0 equal to 4 pi into 10 to the power minus 7. So use this value for mu, and for n use 1000 because this is the number of turns per unit length, and the current I is given 5. If we put all this value here, we are getting the value 2 pi into 10 to the power minus 3 Tesla. So this is the answer. Hope it is very clear. The session, no complication in this anywhere. So today is up to this much, and the chapter is moving charges and magnetism. So up to this total 4 chapter has been completed. So कोई अगर कोई दिक्कत है, you can put your comment in the comment section. Okay, so मेरे साथ बने रहने के लिए धन्यवाद. Bye bye. I'll see you in the next video. Okay, bye bye.